Today we're going to start talking about trigonometry. You ever wondered what those buttons on your calculator are that say SIN, COS, and TAN? Well, I've got the answer for you today. Trigonometry is known as this Greek term for the measurement of triangles. Now, we're talking about right triangles in particular today. We'll talk about other triangles later on next week. Trig ratios it's a ratio of the side lengths of right triangles. So the key thing we're dealing with is simply right triangles. So let's talk about right triangles and their pieces. First of all, this little guy right here is called theta, and really it's like a circle with like a little line through it. And theta is a commonly used Greek letter that represents an angle measure. You'll see it all the time. It is just like we use x for unknowns in equations. We have theta, which is an unknown, an arbitrary angle. Arbitrary meaning just a randomly chosen angle measure. Now, obviously, this angle measure is less than 180 because we're in a triangle. Okay, so the parts of a right triangle. This is always important, and it's always in reference to theta. So wherever theta is, that's where we're going to start labeling things. Now, the hypotenuse always is the side across from the right angle. It does not depend on theta. So the side across from the right angle is that one, and that's the hypotenuse. Now, a lot of you guys will say, well, the hypotenuse is the longest side, and that's absolutely correct. So if you recognize it as the longest side, call it the hypotenuse. But it's always across from the right angles. Now, the opposite and the adjacent are going to change depending on the location of theta. Opposite is always really easy to pick out. Opposite is always the side across from theta. So if I drew an arrow across my triangle, this side right here would be my opposite. OPP. Yeah, you know me. So then what's left is the adjacent side. And adjacent is the side that's touching the theta. So this right here is the adjacent. ADJ is touching theta. Remember, theta is this angle, and the side is touching the angle. All right, but it's always important that you label them in reference to the theta that is given to you. Or sometimes the angle is given to you, just whatever angle is given to you, the opposite and the adjacent are dependent on it. Okay, so we got this big chart here. So this is what you see on your calculator. Oh, drew a crooked circle. This is what you see on your calculator. Do not say sin, cos, or tan. They actually have words that go with them. The first thing is sine. And sine is just S-I-N with an E on it. And the sine ratio, so sine of theta, is equal to opposite over hypotenuse. Now, so you can remember it, it's easy to write it S, big S, with an O on top and an H on the bottom. And some people have this saying. We're going to talk about the saying at the end. Cosine is the COS with I-N-E on the end of it. Cosine of theta is adjacent over hypotenuse. That's that ratio. And again, right here we write the C for cosine and the big A over the H for adjacent and hypotenuse. And then lastly is tangent. Tangent, T-A-N, tangent of theta is opposite over adjacent, so O over A. So we had T-O-A. Now, the way that you can remember it, two different ways. I like to say so, ka, toa. So I feel like a little Indian princess when I say that, so, ka, toa. Some people like to remember this wonderful saying, some old hippie caught another hippie tripping on acid. Oh yeah. So, but look, this S-O-H, some old hippie, is sine is opposite for hypotenuse. Caught another hippie, cosine is adjacent over hypotenuse. And then tripping on acid. And T-O-A, tangent, is opposite over adjacent. So whatever way you want to memorize it, you can. Some people come up with their own sayings. I had someone come up with something with a tiger one time, and they remembered it. Whatever floats your boat. All right, let's try our first example. Our first example says, use theta to set up all the trig ratios. So theta is right here. The first thing you want to do is you want to label everything in reference to where theta is. Now, the hypotenuse is always the easiest to pick out. It's the longest side. It's the side across from the right angle. So my 5 is my hypotenuse. Then you always want to pick out your opposite. Opposite is across from the theta, so that's 3, and that's opposite. And then lastly is adjacent, and adjacent helps form that angle that you're given. It touches that theta angle. So I'm going to come up in the corner of my page, and I do this even when I'm solving problems, and I'll write my abbreviation, SOHCAHTOA. And you need to have that memorized because it's not given to you on the test. And you're going to use it so much in the future that it's easy to go ahead and commit it to memory now. So the first thing we want to figure out is what the sine ratio is. Now we're not given the angle, so we're just going to write sine of theta, because remember these are a function, and theta is like our x here. That's our unknown. So sine is opposite over hypotenuse. Opposite is 3 and hypotenuse is 5, so this ratio is 3 over 5 because that's our opposite and that's our hypotenuse. There we go, pretty simple. Cosine of theta, cosine is adjacent over hypotenuse, so adjacent is 4, hypotenuse is 5. And then lastly, tangent of theta, tangent is opposite over adjacent, so opposite in this case is 3 and adjacent is 4. So that's all we're looking for there. We're just looking for these ratios right here. Can we set them up? Because we're going to use these setups to solve for some unknown sides of our right triangles. So you need your calculator handy, so go ahead and get that out. Alright, so here's some directions. I always like to give you a how-to on how to solve these things. To find missing sides, we're going to find missing angles later on, but to find missing sides, this is what you do all the time. You label all the parts of your triangle, which that's what we did over here on the example 1. We labeled them all, very first. Label all your parts of your triangle. Then you're going to use what you were given and the unknown. What you're given, so you're using the number that's been given to you, because you always have to be given at least one side to figure out what's going on here. You always have to be given a side, at least 2 pieces of information, either a side and an angle or 2 sides, which we'll do 2 sides the next class period. So use what you're given, so a number and the unknown, so the variable you're looking for, to determine the proper trig function. And 3 says you set up the ratio, which is just like what we did on the previous example, and we solve for the variable. Now here's the tricky part though. In your calculator, you need to make sure that your mode is in degree, because angles are also measured in radians, which you don't have to know yet, but we want to make sure it's in degree. So if you press mode, it's go down 3, and the first thing is listed as radian, and the next thing is degree. Make sure degree is highlighted. If it is not, make sure you highlight it, and you just quit out of that. Okay, so let's solve some of these bad boys. It says find each variable. Now the first step says to do what? Label all the parts of the triangle. So this time instead of the Greek letter, we're given the actual angle. But that's still our theta. That's what we're talking about. Now the hypotenuse is the side across from the right angle, which is this 30. So we have our hypotenuse. Now this is our theta, so we're going to label the x and the y in reference to this angle. Across from it is x, so that is opposite. And then lastly, next to it is the adjacent. Now, really what we have in this problem is we have 2 problems in one. We're solving for 2 different unknowns. So I'm going to treat it like 2 different problems. We're going to find out what x is, and then we're going to find out what y is, and we're going to call it a day with this one. So first let's solve for x, and I like to be really organized, and we're going to solve for x, and I'll put it in a little box, and we're going to put all of our work here. Now, I always like to say, okay, well, we've got to use x, and we've got to use what's given to us. So that's the step 2. It says use what you're given, so which is that 30, and the unknown, which is x. So x is opposite, okay, and 30 is hypotenuse. So then we got to figure out which trig ratio we're using. And I'm going to write my trig ratios up top. SOHCAHTOA. So we're looking for, are we using sine, cosine, or tangent? What we got to use, what we're given, and the unknown. So we're given O and H. So which one of these trig ratios have O and H in them? And that's this one, sine. So we're going to use sine for this particular example. So after you figure out which one it is, third step says, set up the ratio and solve for the variable. So we're going to set it up. So we're going to say sine of theta. Now, our angle is 23. That's our theta in this case. Is equal to opposite, which is x over hypotenuse, which is 30. So we have x over 30. Now, you can plug in your calculator sine of 23, and it gives you out an actual number. And we're going to use our calculators for that. So, to get our x isolated, we need to multiply each side by 30. So, when we multiply each side by 30, we can use our calculators to calculate what our x is. So our 30s cancel over here, and we're left with an x. So in your calculator, I want you to literally go in, and I want you to type 30 times, and then press that sign button. It says SIN, and it'll give you open parentheses. Put 23 in there and close your parentheses. So that's going to give us whatever x is. Let's do 1 decimal place, and you get 11.7. So that's the length of that side, is 11.7. Alright, now we're going to find y. We're going to treat this like another problem. So I'm going to write y and put it in a box. So now we're finding y. So first thing we got to do, well, we already labeled it. The second thing we got to do is take what we're given. So we're given 30 and our unknown. So y and 30. And like before, we said that 30 was our hypotenuse. And earlier we labeled that y was adjacent. So we've taken these, and then we have to decide which trig ratio we're using. So we're looking for whatever trig ratio has a and h in it. That is cosine. So we're going to use cosine to solve for this one. So we're going to set up this ratio. So we're going to have cosine of our angle, which is 23, is equal to adjacent, which is y, over hypotenuse, which is 30. And similarly to the one before that, to get the y by itself, we're going to have to multiply both sides by 30. My 30s are going to cancel. So in the calculator, you're going to type 30 times cosine of 23, and that's going to give me my y value. So if you put that in your calculator, you get y is 27.6. So we found both are missing x and are missing y. So really this was two problems in one. Alright, let's do another one. Okay, first things first, let's go to labeling. Okay, the side that's across from the right angle is the hypotenuse. So my y is my hypotenuse. Then we're going to pick the opposite next. Here's our theta in this case. This is our angle. So x is going to be opposite. And then that leaves 5 to be the adjacent. Alright, so we're going to do two different problems here. We're going to find x and we're going to find y. Let me write my sine, cosine, and tangent in the top corner. Okay, so let's find x first. So we got to take our unknown and what we're given. So we're given 5 this time. So our unknown x is opposite, and what's given to us is 5, which is adjacent. Okay. So then we've got to decide which trig ratio has O and A in it. Which one has opposite and adjacent? So that is tangent. So we're going to use this trig ratio. So let's set it up. Tangent of our angle, and our angle in this case is 50, is equal to opposite over adjacent. So that's x over 5. So this is really similar to what we've been doing. Now, to get x by itself, we just multiply both sides by 5. So our 5s are going to cancel. And then we have 5 times tangent of 50 is going to give us our x. So in your calculator, type that in. And when you round it, you get 6. So that's our x. Now the y is just a little bit trickier, and it's not bad, but you really need to pay attention for the y one. So let's find y. So we have to take what we're looking for and what we're given. And y is our hypotenuse, and 5 is adjacent. So then we've got to decide which trig ratio has A and H in it. And that's cosine. So we're going to use cosine. So let's set it up this time. We have cosine of our angle, which is 50, is equal to adjacent over hypotenuse. Now be careful. Adjacent is 5 and hypotenuse is y. So unlike the other ones, our variable this time is in the denominator and not the numerator of our ratio. Now, we can solve this the same way, but there's going to be one extra little step. Now, before we took the denominator and we multiplied each side by, even on the previous ones, we took the denominator, multiplied both sides by the denominator. And we can do that for this one. So we're going to multiply both sides by y. All we're doing is getting the y out of the denominator to make it a little bit easier. Now, on the left-hand side, we have y times cosine of 50, because we can't multiply those together. Our y's cancel, and we're left with just 5 over here. Now, remember, cosine of 50 is a number. We can type that in our calculator and we'll get a number out. Now, to get y by itself, we've got to divide both sides by cosine of 50. Remember, cosine of 50 is just a number. And our cosine of 50s will cancel. So in your calculator, you need to write or type 5 divided by cosine of 50. And make sure you use parentheses around 50. And that's going to give you that y is 7.8. So that's the hardest part that you're going to have to do, the hardest algebra. So just use this one as a template as you're working on your classwork. So the next class period, we're going to work on finding missing angles. So far, we've just done missing sides.